Hello, Zcash gang. Today I'm excited to share a significant breakthrough I've achieved in Zcash wallet synchronization speed. I've made remarkable progress and I'm eager to demonstrate this advancement using ZEC Pages as my benchmark. I chose ZEC Pages as the ideal candidate for my synchronization benchmarks due to several key factors. Number one, transparency. The viewing key is available publicly, which allows anyone to replicate and verify my results. Number two, it has an extensive history. With several years of data, it provides a comprehensive test case. Number three, high volume. The number of transactions and output nodes far exceeds that of a typical wallet, truly pushing the limits of wallet synchronization. In this video, I will demonstrate the complete synchronization of the ZEC Pages wallet from sapling activation height to the current block at this time. This process should complete in approximately 5 minutes. Let's begin by creating a new database and importing the ZEC Pages account using the viewing key published on the website. It's worth noting that I'm working with a sapling viewing key so that all node decryption won't be necessary. We're still going to scan through it. Now I initiate the synchronization process. The starting point is block 41921, which is sapling activation height plus 1. There's nothing on the first block. And then it would work in chunks of 100,000 blocks. At the 1 minute mark, the synchronization has progressed to about block 1 million, meaning that it has processed 500,000 blocks. So that's pretty impressive. But these blocks are mostly empty. At the 2nd minute mark, we enter the spam range. This part of the blockchain is interesting because this is a section of the blockchain that was subject to a spam attack. And that spam attack significantly increased the data load. Typically, this is a section that requires hours to process because 90% of the transactions and the output nodes are in there. But you can observe that my newly implemented spam filter efficiently managed this data. The filter discards these transactions at the server, so the client doesn't even receive them, and it neutralizes the spam without compromising legitimate data. The only users that are known of who are affected by these spam filters are actually employees of the ECC. the 3-minute mark, we have successfully navigated through the spam, and we resumed with the previous synchronization speed. The entire synchronization process concludes in about 5 minutes. This is running on the Mac Air M1 with only 8 GB of RAM. Today, flagship phones have even better specs. To minimize the influence of the network, the Light Wallet server operates on the line through Wi-Fi, while the Warp server, who serves the blockchain data, runs locally on the same computer. And to verify the validity of the synchronization, I checked the message table and confirming that it accurately reflects what the ZEC Pages message boards displays. And we can see that the transaction data and the witnesses are also present, which allows us to make transactions if we had the secret key. In conclusion, this demonstration highlights the exceptional efficiency of the Zcash warp synchronization. The ability to process such a large volume of data, including navigating through spam-heavy sections, in mere minutes represents a significant leap forward for Zcash wallet technology. Encourage the Zcash community to conduct similar benchmark using the other wallet algorithms. We have BlazeSync, we have DatSync, and we have WARP, first version of WARP. By sharing our results on reproducing benchmarks, we can collectively contribute to the ongoing improvement and optimization of the Zcash ecosystem. Thank you for your attention. I'm excited to see how this advancement will shape the future of Zcash, and I look forward to your feedback and suggestions.